What's up, party people? Let me turn this jazz down a little bit. First of all, if you're watching this live, thank you so much. Tap in, like, share, and subscribe. And if you are watching this replay, then do me a big favor and comment. Put a one in the chat. Um, put something in the chat. You can put a Cougars in the chat if you're one of my students. You can put Beef 215 in the chat if you're one of my students. And so this lesson is about Unit 6, Lesson 4. And I titled it Growing and Growing Exponentially because we're talking about exponential growth and we're comparing exponential growth to linear growth. So let's go ahead and stop the music and we are going to get into the lesson. And so when I look at this lesson, I want you all to pay attention to a few things, right? So let's present this. And when we present this, we are going to look at a scenario. So this warm-up exercise is we're talking about what's the difference between these two expressions, right? So we have one expression that says 70 plus 5 plus 5 plus 5 plus 5 plus 5. And then we have an expression that says 70 times 5 times 5 times 5 times 5 times 5 times 5. For the notice and wonder, I'm not going to complete this here online because I just want you all to think of something. If you're watching this replay, put something in the chat that you notice about either one of these expressions. And you can also put something that you wonder about either one of these expressions, right? And so we'll come back to this point later in the live. Now, you got this situation, and for the sake of length, I'm not going to read it all the way through. Please take the time to pause this and read it all the way through. But you have a scenario where a person is walking along the beach and they bump into something hard in the ground. They look down and realize that it is a lamp, okay? And it's sandy, and they brush it off, and what do you know? Whoo! Out pops a genie, okay? Kind of like Aladdin. You all have seen the movie Aladdin, I'm pretty sure. But if you haven't, it's a great movie. You can check out the original one and the live action one. Phenomenal movie. And Will Smith does his thing in the live action movie. So this genie appears. And this genie basically says, hey, thank you for freeing me from the bottle. I was getting a little claustrophobic in there. And so since you freed me from this lamp, I want you to choose one of these purses as a reward. Purse A, which contains $1,000 today. If you leave it alone, it will contain $1,200 tomorrow by magic. The next day, it will have $1,400. This pattern of $200 additional dollars per day will continue. Okay, so it'll go on and on and on, additional $200 per day. But purse B, it contains 1 penny today. You leave that penny there because tomorrow it will magically turn into 2 pennies. The next day, there will be 4 pennies, and that amount in the purse will double each day continuously, okay? So when we look at this, the first question it asks is, how much money will be in each purse after a week and then after 2 weeks? So let's draw a table here, right? And I'm not going to do the entire table because it will take a while to draw. But we're going to do a table here. And in this table, I'm going to put about 3 different rows. Okay, so hopefully we do this neat enough to where it will do the right thing and we'll have space. Because if not, well, we're not going to do the whole thing. So let's do this. Boom. Boom. And we'll do another row just in case, okay? So we're going to draw a table here, and we're going to look at both of these purses, okay? And purse meaning like the amount of money, okay? So when I look at this, I want to say, well, we need to know a couple more lines on here, right? So we need a line here. Let's do here, here. See, this stylus is being a little sensitive tonight. So let's see. All right. And like I said, I'm not going to do each and every individual amount, but I want to show you a few things in this table. All right. And so let's get right into it. So when we're talking about this purse, right? So we want to say purse A. So let me see, how did I do my table? I did plan purse A. All right, so here, purse A, and then we're just gonna say B. Like, let's not write out the words because we don't want to draw out this movie too long. And we're gonna say day. Okay, so we start out with the amount that is originally in here. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. And then I'm going to skip. And then because we have, let's say, 8, 9, 10, and because it's asking for 2 weeks, 11, 12, and let's jump. Well, we can do 14. Let's do 14. And I guess I told a story. So we have enough space for the 2 weeks. So we start out with $1,000. Now, this is on day 0 because this is the amount that is starting in both of these. Now, you can write purse B as 0.01 because we're working with cents, or you can write it as just 1. But remember, because it's cents, as the money grows, we have to take that and add the decimal or divide that number by 100 if we're writing it as just whole numbers, okay? So remember, after day 1, the first one is going to gain $200 each day. So you'll see a pattern. Okay. So as you can see, after 7 days, the first purse will have $2,400 in it. Okay, and I'm going to write these as cents for the second one. So it doubles. It has 2 cents. Then it has 4 cents. And then it has 8 cents. And notice this number is doubling each day. So after 7 days, we have a total of, let's rewind that. So after 7 days, we have a total of $2,400 in purse A, and we have a total of $1.28 in purse B. Okay, if we continue this pattern on, then this number will increase. Let's change that color. So we'll have 2,600, 2,800. Uh-oh. That's 3,600. I mean, 400. Okay, so we see $3,800 in the in the first purse A after the first day. So here we have 256, and then we have this number. Put our decimal. And let me double check my numbers from the table because, of course, I have written this out previously. And then we have let's erase that. Okay, so after 2 weeks, don't want that color. That's not going to do right. After 2 weeks, we have $3,800 in the first purse and $163.84 in the second purse. Okay. So now let's talk about how we get these numbers. It looks pretty simple for purse A. We're simply adding $200 each day. Now with purse B, I'm going to change the color. I want you to see how we're getting these numbers. Okay. So purse B, I start out with 1 cent, or we could say 1. So we could say 1. And remember, it's doubling every day. And when we double something, we multiply it by 2. Okay. So 1 times 2 is 1, or 0.01 times 2. Let's do that version as well. 0.01 times 2 is simply 0.01. But now, because it's day 0, we want to add a 0 as an exponent, right? Okay. So, well, technically, let's go back. Let's take that back. Let's take that back. I don't want to confuse y'all. All right. So we have 0.01 or just 1, depending on how you write this. Because some students aren't going to write this using cents, right? But now the second day, I have this 0.01, but I multiply it by 2. Or I could say 1 times 2, okay? And then the second day, I do the 0.01, and then I'm going to say times 2 times 2, right? Or we could say 1 times 2 to the second power, okay? So remember, that 0.01, we can write it like this. Let's do a different color. We could say 0.01 times 2 to the second power, okay? You can put that 2 to the second power in parentheses. And then the powers continue to increase each time. So I have 0.01, and I'm going to put it in parentheses this time, to the third power, all right? Or simply, if I write it down here, it's just 1 times 2 to the third power, okay? And now, each time I'm multiplying it by 2 for purse B, okay? So that is a pattern. Why are we multiplying it by 2 every time? Because it says it's doubling. But you will see that it continues to form a pattern, 2 to the fourth, 2 to the fifth, and so on and so forth, okay? So that's important. So we know how much money is in there after week 1 and after week 2. Notice after 1 week and after 2 weeks, purse A still has more money, okay? Let's clear this out. And then if we continue this pattern, the next question asks, it says the genie later added that he will let the money in the purse grow for 3 weeks, okay? So we're going to kind of, now that we know, if we continue to add more money each week, right? Here for purse A, we started out with $1,000, and then we say 1,000 plus, we're taking 200 each day, and after 3 weeks, that's 21 days, okay? So if I take 1,000 plus 200 times 21, I'm going to get $5,200, okay? Like I said, I don't want to write out this entire chart because it would take a long time and it would make this video very long. We start out with 1 penny, okay? So I'm going to write this 2 ways. I'm going to say 1 penny, so let's just say 1 for now, times 2, and after 3 weeks, it's 21 days to the 21st power, okay? And so after 3 weeks, they're going to have, it looks like about 20, let's do this. Let's write out the digits. 2097152. Now, that's not the number because it's actually cents. So this is not telling me the amount of money. So if I take this same thing and I do 0.01 times 2 to the 21st power, then I actually will get $20,971.52. Now, the easy way, we could have took this first number right here, and if we divide it by 100, it would place the decimal between the 1 and the 5. Okay, so after 3 weeks, notice that we have $5,200 in purse A, and we have $20,971.52 in purse B. So we know how much money will be in each purse after 3 weeks. Notice now purse B has surpassed purse A. So you have $20,971.52 in purse B, and we only started out with a penny, but in purse A, we end up with just $5,200. Okay, let's go on to the next question and see what it asks. So question 3 says, which purse contains more money after 30 days? Well, we just saw that after 21 days, purse B has more money. So we're going to say this is purse B. And we've already shown that in the previous question. All right, so now let's go on. Let's talk a little bit about the graphs, okay? I'm not going to ask this question, so I'm going to skip here. And it says, which graph shows the amount of money in purse A? Which graph shows the amount of money in purse B? Now, we already saw, so we have 2 graphs, right? So we have one graph that looks like this, and I'm going to do it in the same color that it's in, but I'm going to highlight this, right? So we have one graph here, and I'm just highlighting these. I'm not connecting these by a point. That's the red graph. And then we have the blue graph, which looks down here. And then it slowly goes like that. And then it goes all the way up there. Boom. Okay, so we have the red graph and we have the blue graph. Now, what are we doing? We say which one represents purse A and which one represents purse B. Well, this is kind of obvious. The red, red X's represent purse A. How do you know that, Mr. Harris? Well, because number one, it's continuously growing at a constant rate. And then actually I didn't want to change that color, so let's change it back. Oh, no. Let's do this. All right. And so then let's go here. We'll say and I didn't want that in red, blue, that first one. So let's just write the second one in blue. So we'll say blue circles represent purse B. Okay. How do we know that? Well, we obviously saw that after 3 weeks, purse B had a lot more money than purse A. So if you look at the graph, the blue circles, eventually they go up a lot higher than the red X's. Okay. So then now we want to say points P and Q. All right. So you see the red P down there, the blue Q. And it gives you the ordered pair, and they're labeled on the graph. Explain what they mean in terms of the genie's offer. So let's go to some text, and we're going to say, let's go here. Point P. So point P means that purse B will have $5.12 after 9 days. Okay. And then we have the other point, which says point Q means that purse A will have $2,000 after 5 days. Okay. That is simply because we have the ordered pair. Notice the x coordinate represents the number of days based upon the way this graph is labeled. Here, so x represents the number of days. So that 9 is 9 days. This 5 is 5 days. And then we have the amount in dollars is the y coordinate, $5.12, $2,000. Okay, so that tells us what those points represent. Okay, let's clear this out and let's go to the next slide. It's going to ask us a little bit more about the graph. It says, what are the coordinates of the vertical intercept for each graph? Now, the vertical intercept, remember, that's the initial value. Once again, the vertical intercept is the initial value. So the vertical intercept of purse A is 0 because it's on the y-axis, and they start out with $1,000. Okay, so let's put a dollar sign there just so we know. Oh, a dollar sign, so $1,000. Okay, I didn't mean to do that. All right, so and the vertical intercept of purse B is 0 and 0.01 to represent 1 cent because it starts out with 1 penny. Okay, it says, when does purse B become a better choice than purse A? Well, we can see that from the graph. On a certain day, I don't want to have text anymore. Why is it not? Oh, that's because I'm pressing the wrong button. Here on this day, notice the blue circle is above the X. Okay, so that means that and notice it's on this day right here, day 19. Okay, so this tells us day 19. And how do we know that? Because the circle is higher than the X. All right. Now, question 5 says, knowing what you know now, which person would you choose? It's obvious to anyone. You probably would choose purse B because you know that purse B eventually skyrockets. Okay. So that's this. Notice when we go back to that initial slide, right? So I'm going to go back to the initial slide. What I want you to realize is this, right? I want you to realize, didn't mean to do that. Going back to this initial slide, right? What I want you to notice is that the first one, as we can see for purse A, let's put it here. This represents linear growth because the 5 is being added constantly, over and over. Okay, and let's try to move this around so you can see this. Let's see if I can move it up. Nope, it's not letting me move it. All right, so there we go. That's what I need. Okay, so I want you to notice that this represents linear growth because the 5 is being added, and let's say to the 70 over and over. Okay, now when we go over here for 70 times 5, this represents exponential growth because the 70 the 70 is being multiplied by 5 over and over. Okay, so first one, we're keep adding, that represents linear growth. The second one, it represents exponential growth. Do me a favor. Thank you for watching, first of all, but like, share, and subscribe. Remember, put something in the chat. Put exponential growth. Put B215. Put what city you're from. Like, share, and subscribe to this with a friend.